Okay, so today we're going to do, I don't know how far we'll get, but we have to do single and double replacement reactions. So let's take a look at those. Single replacement reactions, that's where we're going to start. In a single replacement reaction, a reactive element reacts with an ionic compound. So an element is going to react with an ionic compound. Element reacts with an ionic compound. One element takes the place of another element in a compound. So that element we're reacting with, so this element right here is going to switch with something in this ionic compound, right? So we're going to do the old switcheroo here, okay? One element takes place of another element in a compound. Things to be aware of. We need to, again, remember multivalent. So basically those metals that have more than one charge. We need to look at states of metals, okay? States of ionic compounds in a solution, aqueous. Drop and stop for ionic compounds. And of course, if we're talking about elements that might be by themselves, we have to also keep in mind Hofbrinkel. I have no very clever friends, people stupid, yes? Okay, so all those things. All right, good. Now, there's a lot of stuff here, but don't worry about this. I'm actually going to do this on a separate thing here. So we have two types here. They're the same, okay, just so you know. An element is going to switch with one part of the ionic compound. It says type 1, a metal reacts with an ionic compound. So if we had, for example, A plus, let's say, BC, okay, you can put that down on the left-hand side there, A plus BC. This would be my element here, of course, and this would be my ionic compound. The A and the B would switch, all right? The A and the B would switch because it's a metal, and the metal would switch with the metal, right? And if you want to write that down, you can, but when this is a metal here, it switches with the metal. And of course, this would be the non-metal here, yes? Non-metal. Kind of like that, yes? Does that make sense? So, in the ionic compound, we have a metal part and a non-metal part, and so the metal switches with the metal, okay? So those two things would switch, and we'd end up with B by itself here, okay? Because the B kind of comes out, and the A goes in to get AC, all right? Is that good? Yes? Questions, anyone? An example? Yes. Yeah. Well, for our purposes, yes. In real life, no. But yes, because we just, okay? So, yeah. For the test, we do this, okay? In real life, meh, depends. Yeah. All right. So, our example here is this one here where it says iron plus gold nitrate gives me iron, nitrate, and gold. All right. So I think that one's there. Okay. Do you want to go? I don't know. I think that's okay there, right? So do you see how the iron and the gold switch places basically? Okay. And it doesn't matter which one you write first on the product side or the reactant side for that matter. Usually we see this. Like A, the element plus the compound gives me element plus compound. But again, if you wanted to write this first and then this there, that's okay. Doesn't matter. Okay. But you're still gonna switch them. But if you want to write AC plus B is what I'm saying, that's fine. I don't care. Doesn't matter. Okay. Let's look at the actual example here. Silver can be I'm going to do two more examples, I think, just to kind of give you a better, because this is a good one. This is okay, but it's not great, just because it can be confusing for the first time for you here. But it says silver can be recovered from a solution that contains silver ions by using copper. That sounds wordy. You're not usually going to see that, okay? So what you're going to see is the second half. Write a balanced chemical equation for the reactions that occur between a solution of silver nitrate and solid copper, okay? Now, silver nitrate, so basically they're saying, let's write a chemical equation for the reaction between a solution of silver nitrate, solution, okay? So we're going to put AQ there because we basically need to put this into water, all right? And solid copper. Good? Nope. Nope. That would be S. Precipitates are represented by S. Yeah. Solution is aqueous. Okay? And again, it depends on what this is, what this one thing is here. That's going to depend on what you're going to be switching it with. That's copper, so we need to switch it with a metal, right? Because copper is a metal, we're going to switch it with the metal. So we're going to switch these two things here, silver and copper, all right? So copper is going to go into the compound, silver is going to come out, all right? So I'm going to write down silver first here, if that's okay, because that's going to be by itself. And now copper is going to become part of this ionic compound instead. So copper, let's get our periodic tables out, copper nitrate. But the problem with copper is, of course, copper comes in more than one charge, yes? So we always go with what? The first one, yes? So the first one is copper 2. So we're going to go with copper 2. So this is, I'm going to erase this right away, but that's a 2 plus and a 1 minus, yes? Okay. And so I'm going to do the old swap and drop for this compound here, copper 2 nitrate, and that'll be aqueous as well. All right, copper 2 nitrate. We're going to do one more here right away. Good so far? Questions? Anyone? Ask. Don't be shy. Because this is probably the first time you're seeing this here. Now, when we go to balance, of course, we still have to balance it. So to balance it, I'd say, okay, well, there's one silver here, and there's one silver here. So far, so good. Here's NO3, okay? Now you might say, well, there's N. Can we balance it based on each atom? I would say let's probably not do that here because, again, we have ionic compound, and then some elements. So I think this nitrate here, this NO3, is going to match up to that NO3 over there, yes? So if I look at this nitrate, I got, how many nitrates do I have there? 1, yes? NO3 is nitrate. That's 1 NO3. How many NO3s do I have here? 2. So I got to go back here and put a 2 in front, yes? 2 NO3s. I have now 2 silvers, 2 AGs, so I'm going to have to put a 2 there, yes? So you kind of got to go back and start again. That's sometimes what happens. I have a copper here, and I have a copper there. Remember that 2 only goes to what's in the brackets, yes? So that should be good, okay? Pretty typical balancing of single replacement kind of thing. All right, questions, anyone? I think we'll do one more. Sure? Okay. Let's see. Whenever you have an element in a compound water. Well, the ionic compound will actually, we'll talk about that in a second. We'll talk about that. Let's see, which one do I want to do now? Let's do this one. Let's take some magnesium. No, you know what? Let's do this. And you just write this down somewhere, I don't know. Reaction between magnesium and, I don't know, let's go with gold 3. No, I think gold comes in 3s anyway, doesn't it? I don't think I need that, do I? Gold comes only in 1 charge. Oh, does it? Okay. We'll go with gold 3. We'll go with nitrate, I guess. Okay, let's do that one. Why don't you go ahead and start that? And let's see how that goes. So magnesium is an element, of course. So again, I'm going to look on the periodic table. Any element states that we need to have are on the periodic table. Magnesium's a solid. And gold 3 nitrate. I guess my bad. I should have said solution here somewhere. Solution. And we'll talk about that in a second here. So that's going to be gold nitrate 3 aqueous. Okay. Good so far? Is that okay? So magnesium plus gold 3 nitrate, and that I should have said a solution there. Okay. Usually we'll give you that. In single replacement, we need to have that ionic compound in a solution. Okay. There's a reason for that, which we'll talk about in a second. This is a metal, so it switches with the metal, right? So magnesium is going to go in, gold is going to come out. Yes. So gold is going to be by itself, and magnesium nitrate. Now, again, we have to look at charges here. Magnesium forms a 2+ charge, nitrate's a 1-, because I'm doing an ionic compound now, so I have to put 2 here. Yes, like so. Good. Questions, anyone? Oh yeah. Now, quite often magnesium's good, magnesium, gold, gold. Nitrate, I got 3 here and I got 2 there, so we're going to have to do that lowest common multiple thing again, right? So I'm going to make 6 nitrates here, 2 times 3, right? 2 and 3, 6 nitrates. 3 times 2 is 6 nitrates. Good? Yes? Then, of course, I'm going to have to go back and fix the magnesium and the gold here. I got 3 magnesiums there, 3 magnesiums here, because remember that 2 only goes to the nitrate. So 3 magnesiums right there. So 3 magnesiums there, 2 golds, 2 golds. Yes? Is that good? Questions? Yes or no? Okay. So this unfortunately is gonna, whatever. We probably should talk about this now, but so what actually is happening between these two here? Like, do they actually say, like, how does the magnesium know to switch with the gold, you know, in between the two? Is that really what's happening? Like, the magnesium's like, hey, I'm going to switch places with you, and then they're going to switch? Obviously not, right? So what happens with this is we have this metal, and this is just a metal. Let me ask you this question here. I don't know how far we're going to get here today, but let's do a little review here. This will be fun. Okay. Ready? Now think about this before you just start looking. What's the charge on this magnesium right here? What's the charge on this magnesium? Oh, I don't want to go with you two. I'm gonna go with MT. Yes is the correct answer. It is neutral. Yes, because it is by itself, right? This is just a strip of magnesium. There is no charge on that, okay? And that's really important. There is no charge, okay? Now, what's the charge on this gold right here? Nathan. Yes, this has a charge. Why does this one have a charge, but this one does? Well, this is by itself. This is part of an ionic compound, yes? So in order for that ionic compound to work, we've put this one loses 3, and this one gains those 3, right? So obviously you'd say, well, this is a 1- there, yes, and they got 3 of them. That's why they're neutral. Altogether, it's a neutral compound, but technically that charge on that is lost 3 electrons. What's the charge on this gold here? Neutral. And then we got a 2+, yes, and a 1- there, yeah? Okay, kind of thing. Don't, like, you can do that, but I don't want to see that, obviously, when we're writing these equations, because you guys are APs, so you should probably understand what's going on here. Now, nitrate, the only reason, if you notice here, I got nitrate here, and I got nitrate here, yes? And in chemistry grade 11, we talked about a spectator ion. So that's just there. The only reason that's there is to give this one a charge, basically. I could have actually changed that something. But what happens is, let me ask you this. You want to learn grade 12 chemistry today? Sure. Let's get rid of this first. Don't worry. You don't have to don't do that. But I'm going to get rid of that for a second. Let me ask you this question. How does magnesium, think about this, how does magnesium become magnesium 2 plus? How does that happen? How does magnesium, it becomes magnesium 2 plus? Sydney, what do you say? Yeah, 2 electrons are lost, right? So I lose 2 electrons here. Now, 2 electrons for each magnesium, yes? And I got 3 magnesiums to 3, right? So that's times 3, or I'd lose 6 electrons, yes? So that's what's happening with that magnesium. Magnesium's going from a 0 to a 2 plus, and I'm losing those electrons. But those electrons have to go somewhere, right? We know that. Usually they go to an ionic count, they go to the nonmetal. But in this case, look what happens here. Gold goes from a 3 plus to a 0. How does gold become 3 plus to 0 now? It has to what? Yep. Gain 3 electrons. And there's 2 of them, right? So this is gaining 3 electrons times 2, or 6 electrons. So what's happening is the metals are actually, one metal is losing electrons and the other one's gaining those electrons, okay? Because some metals want to gain electrons better than other ones. So they take electrons from somebody else, another metal in this case. This is called reduction. When I gain electrons, I gain negatives, so I call it a reduction. When I lose electrons, we call it oxidation, and it's called the redox reaction. That's what happens here, okay? That's grade 12. We used to do that in grade 11 a couple of years ago when I was, but we don't do that anymore. That's grade 12. So that's what's actually happening in a single replacement reaction. One metal loses electrons and the other ion gains those electrons. That's what's really happening. So there's not like, hey, let's switch, and they like that. All that's happening is electrons are being transferred. That's what's happening. We're going to go to the lab and we're going to watch that happen, okay? Because you can actually see it happen, okay? All right, I don't know if we're going to get to questions. I guess not, eh? All right, we'll call it a day for today. Just make sure you guys study on the weekend, yes? Quiz